All right, hey guys, we're moving on to the next section of this chapter. And on this section, they're beginning to ask us some questions. We've learned how to graph lines using slope-intercept form, starting with the y-intercept and the slope. And so we've learned how to do that, but now they're starting to ask us specifically if ordered pairs are solutions to that equation. And so remember back in our lessons where we've been talking about graphing lines, we've talked about that every point on that line is a solution. That's why we ended up with those ordered pairs that we could create our line off of, all right, is because those were specific solutions to that equation that we were working with. So on this section, they've asked us some questions, and specifically they've asked us, is the point 2, -5 a solution to the equation y equals -1/2 x plus 3? Then they've also asked us if the point 4, 1 will be a solution. So there's really two ways to go about determining this, and we're going to show you both ways to begin with, and then we'll move and show and recognize which one's going to be a little quicker and easier to determine that with. So let's start with the first method, which is to actually test the values in the equation. So this is like what we learned at the very beginning of the chapter, where we're going to plug the information in, we're going to substitute it in, we're going to substitute the x in for the x and the y in for the y. Now before, we substituted one in to find the other. Here we are simply going to substitute both in and see if they end up being the same. So as it says in your notes right here, you're going to replace the x in the equation with the x value, right? Then you're going to replace the y in the equation with the y value, so that's what we just talked about. And then we'll simplify after we've got both those numbers in. What we need to recognize is if both sides are equal, then it is a solution. All right, we should end up with two numbers, one on each side of the equal sign, and they should be equal to each other if it is a solution. If the two sides are not equal, so we end up with two numbers that are not equal to each other, all right, then no, it's not a solution. So some examples of that would be like if we ended up with 6 equals 6, all right? That is the same number, so it is definitely equal to itself. So that would be a solution, whatever ordered pair we plugged in, right? Or if we were to end up with something like 6 equals 5. Those two numbers are not equal to each other, so that means it's the ordered pair that we used to get down to that was not a solution. All right, so let's take a look. So our first one we have here that they asked us about was 2, -5, and they want us to see if it goes into if it is a solution to the equation up here of y equals -1/2 x plus 3. So I'm just going to write that down here to remind myself. Y equals -1/2 x plus 3. Now we did talk about previously that in these spots we could move the x to the top. So if you'd like to do that, which I'm going to move that to the top, and I'm going to end up with y equals -x/2 plus 3. All right, and I'm going to plug into that. Now you could do it the other way, and that's fine, whatever works best for you. So again, with ordered pairs, remember that these are x and y values, so I'm going to call that x, the 2x, and the -5y. And I'm going to plug those into the appropriate spots. So again, I'm going to plug the 2 in for the x, so up here for the x, and I'm going to plug the -5 in for the y over here. So that's what I'm going to do. So let's do that. So in for y goes -5, and that is equal to, in for x goes 2, so I've got negative, and then my 2 over 2, and then plus 3. Now when I simplify this, I should end up with -5 equals -5 if 2 -5 is a solution. If I do not end up with that, then something went wrong, right? Or that means that it's not a solution, right? Not that something went wrong, but that it's not a solution. So first thing we want to do is the left side's already simplified down. It's down to one number, so we need to simplify the right side. So I've got -2 divided by 2. Well, that is -1, and that's all. Everything else that was there is going to come down. And then -1 plus 3, that is 2. So I've got -5 equals 2. Now, -5 does not equal 2, so this is not a solution. So not a solution. So the point 2, -5 is not a solution to that equation of y equals -1/2 x plus 3. All right, so again, let's try that for the next one, remembering 4, 1 is representation of x and of y. So I'm going to plug in my x of 4 in for x, and I'm going to plug in my 1 of y in for y. So let's do that. So 1 goes in place of y, so 1 equals, in place of the x goes 4, so I've got negative, and then 4 over 2, and then plus 3. Now again, if this is a solution, I should end up with 1 equals 1. So let's see if that happens. So first step, simplify the fraction. So -4 divided by 2 is -2. So I've got 1 equals -2 and then plus 3. And -2 plus 3, that is +1, so 1 equals 1. So that does equal each other. 1 does equal 1, and so this is a solution. So the point 4, 1 is a solution, but the point 2, -5 is not a solution. So obviously you can see there, that's one way of solving it. We can plug the x and y coordinates in for x and y and see if it becomes true. But it's kind of a time-consuming process if we're being honest with ourselves, all right? We've got to plug numbers in, we might have to make an adjustment to the equation, and then we've got to solve it all down, right? Sometimes a quicker way can be to actually graph the equation and then look and see, do those points, those ordered pairs, fall on the line? So the first thing we want to do in order to do that is we want to find the y-intercept. So we want to find the y-intercept and the slope from the equation. So remembering our equation is y equals -1/2 x plus 3. That's our equation that we had. All right, let me move that over so we can see it. There we go. Remembering that this is in the slope-intercept form of y equals mx plus b, where m is our slope and b is our y-intercept. So we would do that first. After we've done that, we can then use that information, starting with the y-intercept, graph that point, and then use the slope to create 2 more points and graph our line. And most of you are becoming very proficient at this and very quick at it, but make sure you take your time. Now after we've graphed the line, then we just simply need to check each point individually and see which ones actually fall on the line, right? If the point is on the line, then it is a solution, right? If the point is not on the line, then no, not a solution. And that's all we have to do. So let's go in and let's graph our first equation, or let's graph our equation of our line. Let's graph the line for it. So again, we always start with the y-intercept, so let's list that. The y-intercept is 3 here, so I've got this 3, and that's of course the y-coordinate of it, so my y-intercept is 0, 3. So I'm going to go in and I'm going to graph that point, and let me move this up a little bit so you can see what I am writing. All right, so our y-intercept is 0, 3. So let's go in. Starting at the origin, 0 says don't move left or right, but 3 says move up 1, 2, 3. And there is my first point of my line. The next thing says, all right, well, then find the slope. Remembering that slope is always in front of x, so my slope is right here, and it's the -1/2, right? So -1/2, and we talked about putting that negative to the top, so -1/2. Well, what exactly does that tell me to do? Well, the -1 tells me to go down 1, and the 2 tells me to go right 2. So I'm going to go from the point I just graphed, down 1, right 2, and there's my next point. Then I'm going to do it again, down 1 and right 2. Now again, remember, if for some reason you were running out of space, you could also do the opposite of both of those movements. I could go up 1 and left 2, and that still is a point on my line. So once I've got my minimum 3 points, then I need to go in and I need to actually graph the line. So again, take my ruler, nice and straight, line it up as best I possibly can, and draw my line all the way across the graph, all right? with arrows at each end. And again, we want it to be as precise as possible on this one because we're looking to see if points fall on the line. Now again, the 2 points that we're checking are 2, -5 and 4, 1. And we want to see, do they fall on the line? If they do, then they're a solution. If they don't, then they're not a solution. So let's start with 2, -5. From the origin, I would go right 2, 1, 2, and then -5 tells me to go down 5. So 1, 2, 3, 4, 5. And that is not on my line, so not a solution. All right? 4, 1. All right? Back at the origin, go right 1, 2, 3, 4, and then up 1. That point is on my line, so it is a solution, which is the exact same thing we found algebraically. But as you've probably noticed, this was a much quicker method to figure that out. So really, graphing the line itself, using that information, and then figuring out are the points on the line or not is going to be our quickest way of doing that. So if you would, let's flip over to the next page on the back side of the page we're just on, and we've got one example that we want to go through. All right, so I'd encourage you to pause the video at this point and try this one on your own. Graph the line, right? Then check each one of those points to see if they work and are solutions that fall on the line itself. All right, well, hopefully you checked that out and did it yourself. But let's start by graphing our line. So again, we start with our y-intercept, which is -1. So I'm going to go to the point 0, -1. So from the origin, don't move left or right, but move down 1. So my y-intercept was 0, -1. Then the slope I see listed is in front of the x, which is 2/3. So 2/3 is my slope. And I remember that because it's a positive number on top, that tells me to rise 2. Positive on the bottom tells me to move to the right 3. So from my y-intercept, I'm going to rise 1, 2, move to the right 1, 2, 3. And there is my next point. I'm going to do it again. Rise 1, 2, move to the right 1, 2, 3. And there I've got my 3 minimum points that I need. Now again, if you are running out of space or you just want to do more points, you can always do the opposite of both of those movements. So instead of rising 2, I'm going to go down 2. And instead of going to the right 3, I'm going to go to the left 3. And that will still end up with a point on your line. Now once you've got your minimum 3 points, you can then graph your line. So we want to go in and line this up with the ruler, do the best that we can to get right through the middle of the points themselves, all right? And draw our line. So there we go. Not exactly perfect, but pretty darn close, all right? And should be usable for the line itself. Right? If you feel like you got way off, erase your line and redo it. So then I want to check each one of these points. Right? So 6, 2, I want to check that. So from the origin, I'm going to go right 1, 2, 3, 4, 5, 6, and then up 2, 1, 2. That point does not fall on my line. So that is not a solution. The point -3, -3. So that tells me to, from the origin, go left 1, 2, 3, and then down 1, 2, 3. That one does fall on the line. So I'm going to circle it because that is a solution. The point 9, 5. So that tells me to go right 1, 2, 3, 4, 5, 6, 7, 8, 9. And then up 5. So up 1, 2, 3, 4, 5. And that point falls right there. Now I do remember that I didn't graph my line perfectly. So it looks like it's a little below it, but let me just check by using the slope. So this point was on the line, or should have been. And from there I need to go up 2 and right 3, 1, 2, 3. And look at that, it should fall on the line. So not graphing a perfect line, which you see here from me, can sometimes throw you off. So if you feel like you're really close to it, always check to make sure. So 9, 5 is a solution. -6, 3, back to the origin, go left 6. So 1, 2, 3, 4, 5, 6, and up 3. 1, 2, 3. That point is obviously not on our line, so not a solution. The point 0, negative 1. So don't move left or right from the origin, but down 1. That is a solution because that's our y-intercept. And then negative 9, negative 7. So I need to go left 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then down 7. 1, 2, 3, 4, 5, 6, 7. And that one falls on my line. My line was graphed well enough in that area. So that is a solution. All right, well, that's how you do that. So if you're looking at your worksheet number 4, this is exactly like the process you should be doing on questions number 1 and 2. If you have any additional questions, please let me know, but otherwise you should have what you need to continue on in the notes.